Hello, everybody, and welcome back. Root Beer here, looking at question number 25, the very last question on our 2013 Pascal paper. The GEB sequence, 1, 3, 7, 12, is defined by the following. Looks like we've got three properties. So the sequence is increasing. We can see that already. The sequence formed using the differences between each pair of consecutive terms of the sequence. So the difference between 1 and 3 is 2, between 3 and 7 is 4, between 7 and 12 is 5. This sequence is also increasing. And each positive integer that does not occur in the GEB sequence occurs exactly once in the sequences of differences. And we want to know what's the what's the 100th term in the GEB sequence. All right, well, let's play around with it. So we're given 1, 3, 7, 12. And we've got a sequence of differences forming 2, 4, 5. So these two sequences are going to kind of grow together. Now, I see 7 is in my GEB sequence, the black sequence, but there's no 4. Or, sorry, not no 4. There's no 6. Now, 6 can't come later because the sequence must be increasing. So the next term in my differences sequence must be 6. And if that's the case, then I can work out 18 here. Now, 7's in the GEB sequence, so we skip over it. 8, 9, 10, 11, not 12, and then you'll get 13. And this is allowing me to work out more and more terms of the GEB sequence. But I'm not necessarily seeing a pattern right away. Let's see what we can see. Add on 9, you'll get 35, 45, 56, not 66. Then 69. Now we're meant to figure out the 100th term. I'm not particularly noticing any patterns here. So, So to go from 7 to 12, we add on 5. Now, okay. Let's think about this for a moment. Now, I've got the 18 here. I know the next ones after the 13 are going to be 14, 15, 16, 17. And that's sort of a nice run of numbers. So I know what they're going to be. Do I actually have to add up all of them to figure out what the 17 is going to be? So if I go from 56, the last place there was like a little gap between the numbers. It wasn't consecutive numbers in my differences sequence. It was 11. We skipped 12 because it's in the GEB sequence. We get 13. Is there a way to say, all right, you're at 56, go up to 17? Well, you or go up and add 13, 14, 15, 16, 17. And if so, what's the sort of best way to do this? Because what I'm trying to do is look at runs of numbers. So 2 is by itself, but then you get 4, 5, and 6 are consecutive. And then 8, 9, 10, 11 are consecutive. And then now we've got 13, 14, 15, 16, 17 are consecutive. And I know the next ones will go from 19 up to 26. So this could sort of allow me to jump up by leaps and bounds all at once. Now to add up the numbers from 13 through 17, well, 13 and 17 are 30, 14 and 16 are 30, and 15 is, well, just 15. It's half of 30. So we would add up by 75. So 56 and 75 should get to 131, and that'll be the 12 was the 4th, 5th, 6th, 7th, 8th, 9th, 10th, 11th, 12th, 13th, 14th term is 131. And then we would go up and we'd be working with the numbers from 19 all the way up to 25. And so that would give me another stretch of numbers. Now, I'm still not seeing any nice pattern. I think there are just ways to speed up the calculation, and that's really it. Now, that's not necessarily a bad thing, and maybe I am missing some deeper hidden meaning to the sequence. But and I don't want to just sort of grind out all the way up to 100. So we don't want to actually keep track of the full GEB sequence. But okay. So there's one number missing between 3 and 1. There's 3 numbers between 3 and 7. There's 4 numbers there. There's 5 numbers there. So what we might do is try and figure out, well, how far do I need to go? Right? So let me try this. 7, 12, it was 18, then it was 26, 35, 45. We should at least need to go over 100. So maybe the 131 is what we're going to need in a moment. 56, 69. Let's actually work out these other ones in between. So I'm just going to grab a calculator to speed things up. 69 plus 14, 83. Plus 15, 98. Plus 16, 114. Well, this is not looking too bad because what we've got to 2, 4, 6, 8, 10, 12 numbers already. I think 114 might be all we need, but... And then we add on the 17, we get the 131 that we already worked out. Okay. Now, the differences sequence, the sequence here in red, we're able to work out far more of it well in advance before we actually work out the next GEB sequence term. Okay? And I know how many terms are going to be in sort of stretches of these numbers by taking the difference of the sort of GEB sequence. So there's 2, there's 4 through 6, and so that's one number, that's 3 numbers. There's going to be 4 numbers in between 7 and 12. There's 5 numbers there. These are the numbers 8 through 11 that we already worked with, 13 through 17, 19 through 25. Now, if you look at both sequences together, they are running through the same sort of sets of numbers. So we might be able to use that to our advantage. Like, for example, if I added up every term in the GEB sequence up to 18, and I added up every term up to the 17 in the differences sequence, that would just be the sum of the natural numbers from 1 to 18. So that's an interesting observation. There are 7 numbers in that range. There's going to be 8 in this range, 9 in this range, 11 in between 45 and 56. And then there should be not 13, but... Oh, sorry, no, there should be 10 between those two. And then 12. 13 numbers in that range, 14 numbers in this range, 15 numbers in this range, and 16 numbers in this range. And what numbers are they? 27 through 34. These numbers 36 through 44. 46 through 55. 57 through 68. 70 through 82. Okay. 84 through 97, 99 through 113, and we'll do the last one here, 115 all the way up to 130. That's how many numbers are in between those, and that's 16 numbers in total. Now, suppose I want, let's say, the 9th term in my GEB sequence. Okay? Suppose I want the 9th term, which we can count 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay? How am I going to get this 9th term? Well, it's 1 plus the 2 plus the 4 plus the 5 plus the 6, so all 3 numbers in this range, plus all 4 numbers in that range. And that's 1 plus a total of 8 other numbers. So that'll get you from the 1st to the 2nd to the 3rd all the way up to the 9th. So my 9th term, which we know is 56, should be 1 plus all these numbers. Now, how do you work that out? Well, you could say it's 1 plus 2 plus 3 plus 4 plus 5 plus 6 plus 7 all the way up to plus 11. You say, well, hey, you're color coding some of these numbers. Absolutely, I am. Okay. We can say it's the sum of the numbers from 1 up to 11 and remove the 3 and the 7 that aren't needed to be added on. We're just adding up 2, 4, 5, 6, 8, 9, 10, 11 numbers in these ranges. And if we do that, if we add up all the numbers from 1 to 11, you get 66. More on that in a moment. And you subtract off 3 and 7, you get 56. Okay. So if I want the 99th term, what I need to do is add up 98 of these numbers in the intervals, and I add them to 1. So I'll do 1 plus 2 plus the numbers from 4 to 6 plus the numbers from 8 to 12 plus the numbers from 13 to 17 until we get 98 of them. Okay? But now I can more easily keep track. So actually, we'll go back here. So I need 98 numbers. So adding the 1, 2, and the 3 numbers from 4 to 6, and the 4, and the 5, and the 7, and the 8 numbers, and the 9 numbers, and the 10 numbers. So adding all the way up to 55 should get me 47 numbers. Add on 12 more, 13 more from that, 14 more from that. So up to here, we're at 86 numbers. And then 15. So if we add all the way up to 113, we'll be at 101 numbers being added on to 1. Well, I only needed 96. Or sorry, not 96, 98. So here's what we're going to do. We'll do 1 plus a whole bunch of numbers. I'm more just trying to illustrate the plan. I know what I want to do, but that's not the best way to run a YouTube channel and trying to explain math contests. So it looks like I need to go up to just up to 113, 112, something like that. Anyways, so we'll keep doing this, but if we add up all the numbers from 1 to whatever number I'm about to need, and then remove the few terms that we already know are in our GEB sequence, we will get the final result. It's 13 up to 17. So we'll keep doing that. Now, what do we need to go up to? So I don't need 101 numbers added on. I need 3 less of those. I need 98 numbers added on. So from 100, I don't need 113. I don't need 112, and I don't need 111. So I'll add up to 110. And then I'll remove the GEB sequence from 3 up to 98. Now, why am I focusing on it like this? Well, there's a nice way to add up all the numbers from 1 to a certain amount. Okay? If you want the numbers from 1 plus 2 plus 3 all the way up to some number n, there's a very nice formula. It's very useful in lots of math contests. N times n plus 1 over 2. Okay? So what do we want? We want to add up the numbers from 1 to 110. So that'll be 110 times 111 all over 2, which will be 55 times 111. So that's 6105, but now I need to remove the GEB sequence other than the number 1 that's kind of special, so we'll put it in pink. So 1 plus 98 other numbers, and we've got 98 of them other than these GEB sequence terms. So there should be 12 of them up to 98. Okay. So now we take the 6105 that we just worked out, get rid of 98, 83, 69, 56, I think it was 45, 35, 26, 18, 12, 7, and 3. So that was the sum of 110 numbers. We want the sum of 100 numbers, including our beloved number 1. Okay. Wait, why did I say I want the 99th term? I want the 100th term. So I'll need one more. So it'll be 6216. Okay. So that was the sum of 111 numbers. We need to then remove 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 numbers, and that would be 100 numbers. And that'll give me my 100th term in my GEB sequence. So I would just get to calculating. So subtract 98, subtract 83. This isn't very exciting for you guys because I'm just punching in numbers on a calculator. Minus 18, minus 12, minus 7, minus 3. So in the end, I get 5,764. So I think that should be my final answer. Is that one of the possibilities? It's hiding at the end. It's E. Now, for something like this, you might want to leave it for a bit, come back and try and do the same sort of analysis again. You won't have to try and find your approach again. But, just to make sure that you really have calculated exactly what you need to do. So, for example, we could have done something a little quick earlier to do a little bit of sort of confidence building. So suppose I want the 30th term in the, well, let's pick something that we definitely know. So let's say I want the 12th term in the GEB sequence, right? That's going to be 1 plus some difference, but we have our sequence of differences. We know we go 2, 4 to 6, 8 to 11, and we know how many numbers there are. There's 1 there, 3 there, 4 there. The next one, so that's a 1 plus a total of 8 differences. And I would need 1 plus 11 differences. So we'll go 13 up to, it should be up to 17, but we don't need all of those. So we need the 13, because that's going to be the 8 plus, so that'll give me the 10th one. 14 will give me the 11th, and 15. So if we add up to 15, we'll be fine. So we do 1 plus all the numbers up to 15, which we've got a formula for. Get 120, and then remove the GEB sequence terms from that count. So minus 3, minus 7, minus 12. So that'll be minus 22. And so I predict that the 12th GEB sequence term is 98. Now we already worked this out, so let's go back and double check. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Okay. So if we add up 99 of the terms, which we can double check. 1 plus 3 plus 4 plus 5 plus 7 plus 8 plus 9 plus 10 plus 12 plus 13. Oops. There we go. Is 72 plus 14 is 86 plus 15 would be 101. We don't need the last 113. And we don't need 112, so we should add up to 111, which is what we did. And so it all seems to work out. So very confident now in my answer of E. That was an interesting, if a little awkward, at least with my approach, question. But I found it very interesting. Certainly I haven't seen anything like that on a Pascal for a while. If you had a different approach or a better pattern, by all means, leave a comment down below. I'd love to learn another way to do this question. But I think that's a good way to end the paper there. Nice 2013 Pascal. And if you're interested in more grade 9 level papers, feel free to browse around the channel. I have Fryer papers, I have Pascal papers, I've got harder papers, I've got easier papers. Oh, we've got so many math papers. Just feel free to look around. And I will see you for more math in the future.